Hey everybody, just wanted to show you how to solve problem 12 on our practice set. So notice in this situation we have got a cart starting at an altitude and it's going to fall down this ramp and it's going to go through a loop-de-loop and then shoot off out here. The first thing it asks us to do is determine the speed at point B, which is at the bottom here. So we're going to go ahead and use conservation of energy and just say that the gravitational potential energy, we'll call it mgh, is going to equal the speed energy, which we call kinetic energy, or 1/2 mv squared. And notice that the m's cancel, and your formula just turns into v equals the square root of 2gh. Okay, and that actually calculates when you put your numbers in here of 2 times 10. And your height, by the way, is the total drop, 2.2 to the bottom, which equals 6.6 meters per second. Now, the next thing it asks you to do is determine the force that the track would exert at point C. So that's right here. Now, when we look at this idea of how that force works, we've got our weight vector. We can call that mg. But we also have a support force that we're going to call normal. And those two things provide a net force. Now, if I look at the actual net force equation, to say like the net force being supplied over here is actually going to be equal to, we often would say it's ma, okay? That's what happens when we have a net force. But in circular motion, we actually define this a as v squared over r. So that actually just turns into mv squared over r, which is the net force for what we call centripetal force. Now that is going to equal that net force, the combination of these two forces. And because those two forces are lined up in the same direction, we're going to go ahead and just put them as a sum. They both go in the same direction. Okay. And this is hard that it's not working out okay. So, all right. Good. We're good. Okay. Now, next thing we're going to do then is solve for the normal force, because it does ask us for the force of the track. So I'm just going to say that N equals mv squared over r plus mg. And when I put it together like that, the velocity is an unknown right here. So really what I would do is I do the same problem I did over here for velocity, except that I'm at a different height now. And so because I'm going to be at this top height, given that the radius is 0.8, that means that the height here is 1.6. So it's kind of like this height right here is 1.6 meters. And given that this is 2.2, then I would just know that the velocity right here is actually going to be equal to, say, m, and velocity itself is the square root of 2gh, which I could look at this as the square root of 2g, and then the height in this case is going to be 2.2 minus 1.6, okay? And that's going to be my velocity, but I still need to square it, okay? And I can go ahead and put my mass in there, which in this case it is, oh, what is my mass? 0.08 kilograms. Okay, and I can put that all over here, and then my radius right here, again, is 0.8, plus mg is 10 times 0.08, and actually this is 0.08 over here, okay, boom, boom. And then we end up with our answer right here, which is 0.43 newtons, okay. All right, now the next thing I'm going to do is figure out, well, what is going to be the speed that the car will shoot off of here? And when I think of that, I notice that I've got a situation where I'm actually going to be shooting off at an angle, okay? And my angle is 40 degrees. And I notice that my speed right here is going to be from my equation here that we used before. Whereas in this case, the height is going to be the drop from the total height, 2.2, to this height right over here, okay, which is 1 meter. And so if I notice right here, my mgh, I'm going to say mg, in this case, h is height minus my original height, okay? And that's going to equal 1/2 mv squared. And then when I put that all together, I can notice that my masses cancel right there.